So we want to prove, right, that these two vertical angles are equal. We want to show that angle 1 is definitely equal to angle 3. And so what we're going to do is we're going to name our lines. We're going to call this first line A and the second line B, okay? And so to do any proof, now if you guys remember, you have this proof notes worksheet. Remember you guys got that for me, what was that, a couple days ago? You guys remember this one? If you take it out right now and kind of put it next to you, you'll be able to help with the reasons as we go through our proofs today. But what we really want to do is take a look at the back page. All right, our steps to do a proof are pretty simple. Number one, we're going to make a T-chart, okay? So a T-chart just basically looks like a big T. All right, we're going to put the statements part over here and the top on this side and the reasons on the other one, okay? So any statements you have, like these two angles are equal, these add to 90, those all go in the statements column. And then the reason, which would be like what's on the front page here, all these bold statements, these are what's going to go in the reasons column. So if you want to say two angles add to 90, we might say like definition of complementary angles or complementary angles add to 90. That's sort of what we're looking at when we do a proof. So if I look at my worksheet, our job is to prove that angle 1 is equal to angle 3. So we're going to name this guy right here. What do you want to call that point? Pick a letter. D. We're going to call that point D. So we're going to put a D right underneath. And so what we're going to do is we're going to do our T-chart. Okay. It's a big T. What do I put on the top of the left column? What do we put on the top of the left column? Statements. Okay. And then the top of the right column, we're going to put reasons. And we're always going to start with whatever we know about the question to begin. These are like our ingredients that we're starting with our recipe. So I know that lines A and B, okay, intersect at point D, at D. And the reason is going to be given. That's what we're starting with. Those are basic knowledge of what we know so far about the proof. Okay? Based off of what we know about proofs and our knowledge, which is right now is limited, but we'll get there. Okay, we've already done steps 1 and 2. We made a T-chart, we labeled the top statements, we labeled the other column reasons. We put down the givens from our proof, which is what we started with from the question. We put down the reason given. Our job now is we're looking for, okay, anything we know is congruent from the given, any keywords in the given like midpoint, right, triangle, perpendicular, bisect to help us build new statements, or can we use the diagram and can we look for straight lines, right, shared angles, right angles, things that are already marked or we know about there for us. Does that make sense so far? Okay. And we're going to keep making statements until we get to the proof statement. That should be our last statement. It's the proof statement. All right. So let's go back to this page right here. And based off of what we know about our diagram, what other thing can you tell me, besides vertical angles, besides 1 equal to 3, what other thing can you see based on the picture? Okay. Good. 1 and 2 equal 180. So angle 1 plus angle 2 has to equal 180 degrees. Why do you know that that has to be true? What have we learned so far this year that tells us this has to be true? What vocab word defines that picture? I mean, okay, why are they supplementary though? Because they form a straight line. Put down for ourselves. All right. And if you look at the proof, worksheet, you can see right on the front, that's going to be definition of a linear pair. Or angles that form a straight line add to 180. One of those things is going to go there. Now, is that the only two angles that we can say that that's true for? What other angles? Go ahead. 3 and 2. So we can also add to that statement and say angle 2 plus angle 3 is equal to 180. And all we're going to do is just add a comma to the first statement here, okay? And say, you know what? I can also add this to it for the same reason. So if you're using the same reason, just add it to that same statement, okay? Now, my job is to get to here and say angle 1 is equal to angle 3. Right now I have two separate equations. In order to do that, I need how many equations? I have 2, and I want to get 1 equal to 3. I need how many? Just 1, right? Just 1 equation. How do I go from these 2 equations into 1? What do we know about the equations? They both equal. So all I can do now is set them equal to each other, okay? So I'm going to take these 2 equations and I'm going to set them equal to each other. I'm going to say angle 1 plus angle 2 is equal to, what's the other equation? Angle 2 plus angle 3. And the reason we can do that is because they both equal the same amount. They both equal 180. And so the actual property we're going to use is called the transitive property. This means if 2 things equal the same amount, they have to be equal to each other. Okay? What would I do to that equation to get 1 equal to 3? What do I want to get rid of? 2. So I would do what? I would subtract it. So we're going to call this statement 5. We need to put a 4 in there, and we'll talk about it in a second. We're going to say that angle 1 is equal to 3, and we can say this is the subtraction property of equality. Right? And what that means is if I subtract the same amount from both sides of an equation, it's going to stay equal. Okay? The only thing we have to do first is make sure that what we're subtracting is actually equal. So we have to say, okay, and it sounds silly, but we actually need to say that angle 2, okay, is equal to itself. Angle 2 is equal to angle 2, okay? This is like, we kind of call this like the silly property. Like, it sounds really ridiculous that I have to say this, but I got to say that it's equal to itself. So when I subtract it, it goes away. This property is known as the reflexive property. Okay? And that proof is now finished. So I know it's done because the proof statement was supposed to be 1 equals 3, and I've just shown that 1 is equal to 3. All right? So let's do a proof, but using algebra. All right? So what I want you to do is I want you to solve this equation off to the side. So off to the side over here, make a line for you guys. All right. I want you to solve your equation over on the right here. So go ahead and solve your equation right over there. All right. So we've ended up with this solution. Okay. And so this is the correct answer to this. And we know that we were supposed to prove, that x was equal to 10.5, and that's the last statement here. So that's the last thing we wrote, so we're good. So in a proof, we don't actually show our work. We just give you the equations that you go from one to the next. So if I was actually doing a proof, which we're going to do in a second here, okay, what I would do is I would write down this first equation right here, okay? I would write down the second equation right here, and the third equation right there. I would not show you the minus 2x, and I wouldn't show you the divide by 2. I'd just give you the equations, okay? So let's do it. Let's actually do the proof, okay? So we're going to take, how do we do a proof again? First thing we do is T-chart, right? So let's do the T-chart. We put statements on the top. Reasons on the top of the other one. And we put our givens down, okay? And given, okay? So the two lines are intersecting, see the diagram, all right? And we put down the given. All right. So the second thing we're going to do is put our first statement right here down. That's the equation. Okay. So our equation was 2x plus 21 is equal to 4x. And we need a reason for that. How did we know that we could build that equation from the picture? Good. So we're going to put down vertical angles are equal. That's it. Okay, without showing our work, what was the next equation we ended up with? That's it, 21 equals 2x. And what did we do to get there? What did we do to get there? So the reason would be the subtraction. How's it finish? Good. Property of equality. All right. And then the last thing I did was we ended up with the last equation, which was 10.5 equals x. And the reason for that, what did we do to get to that step? So this would be the division property of equality. All right. And that's it. I'm done with my proof because my proof statement's the last statement, and we're good to go. All right, so let's take a look at the next one. Okay. So we're doing this proof. The given is that angle 7 is congruent to angle 3. Our job is to show, okay, that angle 7 is congruent to angle 1. There's two ways to do this. We're going to do this two different ways here. Okay, let's fix this. All right, so I start with the proof statement. I start with my T-chart, statements and reasons, okay? Got my givens down, and we should be ready to go. So what I'm going to do is I'm going to mark anything I know from the givens on my diagram. So I know that angle 7 is congruent to angle 3. I'm going to go ahead and put an arc on those two angles to mark it off. My job is to show that 3 is congruent to 1. So take a minute, think about it. How are you going to get from 7 congruent to 3 to show that 7 and 1 are equal? How are you going to show that? Okay, think a minute. Think about it for a minute. Don't write anything down, just think. Okay, so what we noticed was that 3 and 1 are vertical, and if all three angles are equal to each other, then 7 has to equal to 1. So here's how we're going to write it down. We're going to do that step first. So for 2, we're going to put down angle 3 is equal to angle 1, and the reason's going to be, what's the vocab word? Vertical angles are what? Good. Are either equal or congruent. Okay. So for step number 3, and this is the last one, since 7 is equal to 3, 3 is equal to 1, then angle 7 has to be equal to angle 1. And what property did we just use there? The transitive property. All right. Now there's another way to do this. So we're going to put a line underneath, and we're going to go ahead and do one line. Okay. We're going to do this using parallel lines. Okay. So what type of angle pair are 7 and 3? Okay. And what type of angle pair are 7 and 1? Alternate exterior. The only time the alternate exterior angles are equal is if the lines are parallel. We don't know they're parallel yet. Nowhere does it say they're parallel. But we can use 7 and 3 to get them parallel. So for 2b, for called 2b, okay, we're going to say that the two lines A is parallel to B, that lines A and B are parallel. Now remember from the video you watched the other day, we did this. Remember, when we want to write this up, we're going to say, okay, if And what's the angle pair we already have? 7 and 3 are. So if corresponding angles are congruent, what do we know about the lines? They're parallel. So the lines are parallel. And now that we know the lines are parallel, and we can go ahead and mark little arrowheads on the line to indicate the parallel part of it. Now we can say what we wanted to prove, which we'll call it 3b, is angle 7 is equal to angle 1. And now we have to use our parallel line statement, except we have to switch it. So now we're not going to say if the corresponding angles are congruent. We're going to start with if the lines are parallel. But it's a little different this time. It's if, okay? We're going to say parallel lines are cut by a transversal. Then what type of angle pair do we have again? Good. Alternate exterior angles are congruent. Okay? Those two statements are essentially the same, that they'll always be the same. You're not going to change anything except for the angle pair. So this corresponding angles are congruent thing is going to switch, and this part right here is going to switch. That's the only thing that changed about the two statements. You're going to put the angle pair and the relationship in, but that format's going to stay the same. That make sense to you guys? Okay. So for homework tonight, I want you guys to go to the next page, and I want you to try these 3 proofs, okay? So you should start with definitely the givens and see if you can get any other new statements, okay? Just try to get some new statements and see if you can get all the way down to the proof statement. All right, that's it for tonight, guys. We'll see you tomorrow.